We've only got 50% battery, and I know that sounds like a lot, but for some reason, that's how much I use per class now. So we'll see. All right, so we're recording. We've got notes. We've got it all figured out. Okay. So I was feeling the pressure. We're slipping behind. That's okay. I'd rather take our time in chapter 1, establish all these rules, really have a good handle on the rules of the game of math, right? And then we can play the game better later on. And so I just think it's really fun to think of it as a game. So that's what I do. But anyway, so I did ask you to read through and try some of these problems, right? Were there any problems from 1.3 or 1.4 that you think we should go through, or should I just pick some random ones just to check in? How about then, I'll just go through and pick a problem from each kind of problem set. We can work through it together. How about? All right. So, man, it is hot up here now. Maybe it's a sweater. Too hot. Oh, oops. Hey, it disappeared. Math 120. Whoops, 120. All right. So today we're going to start section 1.3, which is on algebraic expressions. It's going to talk about things like expanding, factoring, right? And so just to try to get a handle on these things, let's see here. Right, and so polynomial, do you guys remember what a polynomial is? Right, probably from just life, but a polynomial, right, is anything that looks like, well, any one of these, right? So if you only have a coefficient, and then you have an x, and then maybe it's squared, or to the power of 3, or to the power of 18, or whatever, and then you can add all these terms as many times as you want, right? And so anything that looks like that is a polynomial. And so if we're going to work on a problem, let's do 22. I don't know. Right, so the question says, find the sum, difference, or product. Essentially, just expand this. And so I'll say that this, we're going to expand. And then I'll just paste it in. 22. So, and I am going to get lazy because there was a change in my schedule, and now I'm teaching 4 courses instead of 3. And I've been blah, blah, blahing since 8 o'clock this morning. Go, 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 go. So now I'm lazy. Sit up here. So we want to expand this. Right, and so what we're going to do is on the one side, I'm going to write out the original equation, and then I'm going to say equals, and then I'm going to start expanding, right? It's probably going to take a couple of steps, but that's how I'm going to set it up. And so I want 4 times x squared minus 3x plus 5, minus 3 times x squared minus 2x plus 1 equals we can start with the 4, right? And we have to bring it on to each of the terms inside there, right? And so we get 4x squared minus 4 times negative 3, right? Wow. Plus 20. And then we have to be careful with the minus 3, right? Because you're actually multiplying negative 3 onto each of these terms, right? So if you have a positive inside, then it's going to change to a negative. If you have a negative inside, you have to change it to a positive, right? So you have to be really careful about that. And so we get minus 3x squared plus 6x. Nice. Nearly ran out of room. Too lofty on that side. All right. If we're going to expand, I guess I should say expand and simplify, because we don't just want to leave it like this, right? I can look and we should collect like terms, right? So I've got a 4x squared, I've got a minus 3x squared, I've got 12x, 6x, right? So if I, just to illustrate where it's coming from, it's not something that you have to do. I'm just going to group my like terms, and then it should be obvious where they're coming from. 4x squared minus 3x squared, I'm going to put in brackets just to show that, hey, these guys are going to get combined into 1. And then I'm going to do plus negative 12x plus 6x. If you wanted to do minus, right, but then inside the brackets, you would have to do 12x minus 6x, right? So you want to be careful there. And then plus 20 minus 3, right? Collecting all your like terms. So now we can add and subtract the coefficients, right? So 4 minus 3 makes 1x squared. You can drop the 1, right? I'm just showing that that's what it would be. Minus 6x plus 17. And then dropping the 1, that's all I'm doing here. X squared minus 6x plus 17. Nice. Okay. So definitely we're able to do all of those. I'll just steal it from here. No, because there is no equal sign in there, and so so we won't be able to solve it, right? In order to solve something, we would have to have an equal sign, and so we're just simplifying. Yeah, yeah. Don't worry, we will get to solve stuff. FOIL. To be honest, FOIL doesn't help me at all. It doesn't make sense to me. It stands for first terms, outer terms, inner terms, and last terms. For me, I just remember, well, this one, right, however many things I've got in here, right, this one has to get multiplied onto each of these, which is what we just did, right? And so we know what we're doing here. And then the next one has to get multiplied on all of these. And so we're just expanding even more, right? And so it specifies to use FOIL. When we're multiplying algebraic expressions, we're still going to use FOIL, right? And so I'm going to pick one from this next section instead, but you should definitely be able to do from the first section, right? But let's pick a little bit of a harder one, because I feel like you guys are feeling pretty good. So, 51 or 58? You got it. There's 51. Is that the one you wanted? 51 to start? Oops. let's start there. So we've got the square root of x times x minus the square root of x. I would say that the easiest thing to do here is to convert your square root of x to x to the power of 1 over 2, right? Because then you can manipulate the powers, right? And so what you get is you've got root x, oh, I should give myself more room here. Root x times x minus root x is the same as x to the 1/2 times x minus x to the 1/2. Being a little bit more careful here, right? If I have x to the 1/2 times x, right, then that's the same as x to the 1/2 times x to the power of 1 minus x to the 1/2 times x to the 1/2. These are all the same base, right, which means that I can add those exponents to combine them. And so I get x to the 1/2 plus 1 minus x to the 1/2 plus 1/2. Okay. So now I'm adding fractions, remembering that I have to have a common denominator to add these fractions, right? And so 1/2 plus 1, I'm going to have to rewrite the 1 as 2 over 2, right? So that they're both over 2. And so what I get is x to the power of 1/2 plus 2 over 2. And then x to the power of 1/2 plus 1/2. Those are both over 2, so I can combine them, right? 1/2 plus 1/2 makes 1, right? Or technically 2 over 2, which we reduce to 1, right? But let's write that out, 2 over 2. Just to see where things are coming from. And then we get, on the first term, we get 1 plus 2 over 2, which is x to the power of 3 over 2 minus x to the power of 1. Which is going to be x to the power of 3 over 2 minus x. And I cannot remember. No, we talked about how we can rewrite x to the power of 3 over 2 as the square root of x to the power of 3. I feel like we talked about that.
Which is just x square root x, right?
It is, yeah, it is. So you can separate them again if you want, or keep them separate. But I'm going to write them as the square root of x to the power of 3 minus x. But there's a couple of different options for that x to the 3 over 2, right? You could keep it as x times root x, pulling out that x. There's a couple of different options, which either way I would consider simplified. Okay, nice. Any questions with that one? So what was the other one that you guys wanted done? 58. Oh boy. One thing to keep in mind though, right, because here we've got all these square roots and such. Notice that as a rule, the square root of x times the square root of x, it just gives you x, right? And so we can just go straight to that if we remember that, right? The square root of x times the square root of x is just x. So 58. All right. We've got the square root of h squared plus 1 and then plus 1 times the square root of h squared plus 1 and then minus 1. All right. One thing that we're going to have to do here, right, is we're going to have to treat this square root of h squared plus 1 as one thing. Right? And so that's going to be key. And also, we cannot break up the square root. We're allowed to do that if we're multiplying or dividing in here, but not when we're adding and subtracting, right? So that's why we have to treat it as one thing. Otherwise, there's illegal math in there. So if we start with the square root of h squared plus 1 and then plus 1 times the square root of h squared plus 1 minus 1, treating that square root of h squared plus 1 as one thing, right? The square root of the same thing times the square root of one thing times the square root of the same thing, we can just drop the square root, right? That's what we saw earlier. And so what we get here is we get the square root, of h squared plus 1 squared. And then the square root of h squared plus 1 times negative 1, right, means that I get minus the square root of h squared plus 1. And then plus 1 times the square root of h squared plus 1. And then 1 times negative 1 puts me at minus 1. Question? Repeat? Is that what you said? Yeah. So here, I'll show it with some arrows, right? So this times this, right? That's this term. Yeah. How about orange? This times this, that's this term. This times this is this term. Running out of colors here. And then this times this is that term. But notice how for each of them, right, you have to go from, this one has to multiply every term in the other brackets. Right? And same thing with the next term. Okay. We can simplify this though, right? Because, well, I can see that this square root would go away when I square it, right? I can also see that if I'm taking the minus square root of h squared plus 1, but then I'm adding the same thing, right? Those are going to go to 0, right? And so a lot of this is going to disappear because what I'm going to have is I'm going to have h squared plus 1 plus 0 minus 1. Oh, I'll show where that came from, just to be proper. And then minus 1. So now I have h squared plus 1 minus 1. That's just h squared. And there's nowhere else for us to go with that h squared. So then we're done. Nice. Any questions about that one? No? So definitely work through these exercises. Make sure that you've got that pattern down, right? But you'll see that it's just going to be a matter of just boom, 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 boom. And then simplify.
Excuse me,
Yes?
can you just explain the 60 equation?
60, 60, yeah.
Positive plus signs.
Mm-hmm. We can just do it. So 60 then. Again, what I would do is I would probably treat this term as one thing. That's one option.
Okay.
Another option is these brackets aren't actually doing anything, right? And just to show you guys how that works, let's have a look at what that does, right? And so this, because I'm just adding in here, right, I have to make sure that I bring this negative inside, but that's the only thing, right? And so this plus 1 just gets added or multiplied in. And so that's going to look like this. So if we have x plus 2 plus x squared times x minus 2 plus x squared, that's going to be the same as x plus 2 plus x squared times, right? So now we've got more than 2 terms that we need to deal with, right? But the procedure is going to be the same. So times x minus 2 minus x squared. Making sure you bring that negative onto both of the terms, right? Not just the first one. Okay. Inside each of these brackets, I can't simplify anymore, right? Here's an x term, here's just a constant, and here's an x squared term. So I can't collect and simplify. If I could, that's something I would want to do, right? Because then it's less work when I have to multiply them on, right? But what we're going to do is we're going to take this one times this one, plus this one times this one, plus this one times this one, plus this one times this one, this one times this one, this one times this one, plus this one, plus this times this one, plus this one times this, blah, blah, right? And so it just gets very tedious, right? But as long as you make sure that you've multiplied all of them and you're adding them all up, then you'll be safe. So I can already tell that I'm going to need a lot more room. So I'm going to make an exception. I'm going to move my equal sign over to the far left. Usually, right, I like the equal sign stacked on top of each other, but now I need room, so I'm going to put it over here. So I'm going to start with x times x makes x squared, x to the power 2. X times negative 2 puts me at negative 2x. X times negative x squared puts me at minus x to the power of 3, right? And so I'm not showing that I'm adding the exponents anymore, right? We can stop doing that if you feel comfortable. But you know that it comes from x to the power of 1 times x to the power of 2. X to the power of 1 plus 2 makes x to the power of 3, right? So you know that now. And then plus 2 times x plus 2 times negative 2 puts me at negative 4. Plus 2 times negative x squared minus 2x squared. On to the third term, right, is going to be x squared times x, which is going to be plus x to the power of 3. X squared times negative 2, negative 2x squared. X squared times negative x squared puts me at negative x to the 4th. And I'll show where these things came from. So this x made these guys, right? The first 3. This 2 gave us the next 3. And then this x squared gave us the last 3. Right. Now, we can collect like terms, right? We can collect all the x squareds, all the x to the power of 3s, all the x to the power of 4s, all the constants, right? And so I'm going to rearrange them so that they're all where they're supposed to be. And I can't remember if it says, but usually for polynomials, this is a polynomial, right? It's a big, big polynomial because we've just got x's and constants and powers, right? So it's just a polynomial. What was I about to say? Oh yeah. usually we write them from the largest power down to the lowest power, right? And so when I'm rearranging these, I'm going to start with, it looks like my highest power is the 4, right? We also say that this is a polynomial degree 4, right? Because that's the highest power. So making sure that you keep that negative on the x to the power of 4, we can write that out front here, x to the power of 4, negative x to the power of 4. And then I'm going to deal with all my x to the power of 3's. So I'm going to do plus and then minus x to the power of 3 plus x to the power of 3. That's the only one I see here. And then moving on to my x squared plus x squared minus 2x squared minus 2x squared plus, and then minus 2x plus 2x. Oops. And that looks like that's it. Plus minus 4 is the only constant, so I'll just do minus 4. Nice. Okay. One thing that I like to do, the reason that I wrote them out like this individually is so that I can just count to make sure I have the same terms, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So at least, unless I wrote them down wrong, at least they're all there. So now I'm going to simplify them. If you feel confident, then you can just skip straight to the next step, right? You don't have to show them grouped together. And so we get negative x squared, x to the 4 plus 0, right? Plus 0 plus x squared minus 2x squared minus 2x squared. Or minus 3x squared, right? Because you have minus 1 minus 2 minus 2, right? So what you can do is you can just look at the coefficient here. There's a silent 1, let's call it, right? So 1 minus 2 puts us at negative 3. And then we tack on the x squared, negative 3x squared. Minus 2x plus 2x plus 0 again, and then minus 4. So this is going to simplify to negative x to the power of 4 minus 3x squared minus 4.
Do you pull out the negative?
You can. Nice. So we see that there's a common negative, right? And so what we could do is we could factor it out, right? And say, okay, well, negative x to the power of 4 plus 3x squared plus 4, right? That's equivalent to this, because if I pull this negative back inside, then they're the same. Right? So you could do that. You're allowed to leave it here, right? But that's a good extra step to be thinking about. Nice.
Can you go over how you got the negative 3x? Just that part confused me.
Yes. Negative 3x squared. This one? Oh, so here, I'll scroll up here. Technically, there's a kind of a silent 1 here, right? And so what you can do is you can say, okay, well, actually, what color? Here. You can say that this is the same as 1 minus 2 minus 2, and then all that is times x squared, right? And so 1 minus 2 minus 1 minus 2 is minus 3, right? Okay. And so then we get the negative 3x squared. Nice. That will come up a lot. So if it's unclear right now, then yeah, let's talk more about it, because it is going to be really important. So good, 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 good. All right. Any questions? Other questions? So the handout has these special product formulas. I don't find them very helpful because I would rather probably just do it and simplify it, right? And so you don't have to memorize these or anything. Later on when we get into factoring, it's going to be the exact same table, but flipped. Okay. So it is good to be able to recognize that, oh, something that looks like a plus b times a minus b is going to be one of these special products, but that's later when we get into factoring, right? And so for now, the special product formulas, we don't really need them because we're able to do things like a plus b times a minus b just by hand, okay? So if you tried it, you would end up with a squared minus b squared, right? Same thing if you had a minus b to the power of 3, that's a minus b times a minus b times a minus b. So same idea, right? Let's just have a look at it. So if you have a minus b to the power of 3, right? This is the same as a minus b, oops, times a minus b times a minus b, oops, right, 3 times over. What I do is, it doesn't matter kind of which order you do it, but what I do is I expand these guys, right? So I expand these ones, I just focus on these two. And then when I have something, just a simplified term here, then I take that times a minus b, right? And so what I would end up having is I would have something like a squared, a times negative b makes negative ab. And then because I'm going to collect these, I'm actually going to write it as minus ab again, right? Even though it's minus ba, but because I'm multiplying, the order doesn't matter. So minus ab, and then, oops, plus, because it's negative b times negative b, so plus b squared. And then all that is going to be times a minus b. Before I'm going to go ahead and do this, I'm going to simplify the ab term, right? Because that's just minus 2ab. And so what I get is I get a squared minus 2ab plus b squared, and then times that by a minus b. Now I can go ahead and I can say, okay, well, a squared times a is a to the power of 3. A squared times negative b is minus a squared b. Minus 2ab times a puts you at minus 2a squared times b. And then plus 2ab squared plus ab squared minus b to the power of 3. Just being careful, right, that you drop each of the terms onto the other bracket. But now I can simplify this, right, because I've got a to the power of 3, there's only one, but I've got plus negative a squared b minus 2a squared b, right, has an a squared and a b in there, so those are going to be linked or lumped together, and then plus 2ab squared plus ab squared minus b to the power of 3. So now I have a to the power of 3 minus 3a squared b plus 3ab squared minus b to the power of 3. Which is the same as our special products here, which I'll steal. So we don't actually need these special products, right? Because we're able to do it, but if we're feeling lazy, right, then we could just go straight from here. That's that one, right? And we did get the same answer. Even this first part, right? A minus b times a minus b, that's a minus b squared, which by the special products, right, we get a squared minus 2ab plus b squared. That's where we landed here, right? And so we know how to do all these. Right? We don't actually need a table of all these things. So you can use the special product formulas, right? Or just do it by hand, as I'll probably call it, right? We're just doing it as a machine, right? And so I'm not going to do those now because that's just the same as what we've been doing. But let's get into factoring. So factoring, right, so what we've been doing is we've been expanding, right? And so we've been expanding, making things bigger, removing brackets, right? Factoring is the opposite of expanding, right? So now we're pulling out these common multiples and we're trying to get it as nice and small as we possibly can, right? And so it usually means introducing brackets, right? Like we did when we pulled out that negative, right? We said, well, there's a -1 on all of these. How about I just pull that guy outside and make it look a little bit nicer, right? And so if you're factoring, right, then you change this into something kind of with brackets, right? So you rewrite it usually just with brackets, right? And so depends on the goal, but expanding is when we're expanding and getting rid of these brackets. Factoring is usually done because we want to cancel something, right? So if we've got some nasty thing in the denominator, right, the bottom of our fraction, and we want to cancel it, then usually what we try to do is we try to factor some part of the equation to make it easier to cancel. For example, if you had this on the top, right, but you had an x minus 2 on the bottom, you could rewrite this. So for example, steal this here. We usually factor to be able to easily cancel a term, right? So in this example, if I had x squared minus 4 divided by x minus 2, right, that's actually kind of hard to do because you can't just cancel an x because there's, in this case, subtraction in there, right? Whenever there's addition or subtraction, then we would have to cancel on both terms, right? So in this case, that's kind of hard to do. But if we know that x squared minus 4 can be rewritten as x minus 2 times x plus 2, Well, then we get x minus 2 times x plus 2 divided by x minus 2, and I'll put it in brackets just to show, right? But now, if I treat this as one thing and this is one thing, now I'm doing a times b, right, over a, right, because this one is the same as this one. Now I'm allowed to cancel this because I'm multiplying up here, right? And so now I'm allowed to cancel it, and all of a sudden, it looks very reasonable. Right? So factoring, I've never met anyone who likes factoring. You like factoring. You're the first person I've ever met who likes factoring. Because, and I even find that for me, it's easier to expand, right? You just boop, 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 boop. Right? Add them all up, simplify. Factoring for me feels like, how am I supposed to know what I'm pulling out, right? How am I supposed to know what I'm looking for, right? And so what we're gonna start looking at is, well, if you have x minus 2 on the bottom, see if you can pull out an x minus 2 out of here, right? See what you can do to try to get an x minus 2. And if you can do that, right, using special products like this, for example, right, then that's a good start. Okay? Because now you would be able to cancel this and this. And so now you can say, well, that's just equal to x plus 2. So that's, oh, say that again.
That probably becomes a little more redundant when it gets longer on the top.
Yeah.
It gets like a lot harder to just separate the one thing and figure out the whole. Might as well just figure it all out.
Yeah. Yeah. So this is a little mini example, right? We'll do more. But yeah, so you could have a big kind of nasty thing that you're dealing with, right? But the end game is going to be the same, right? If you've got something in the denominator typically that you want to cancel or try to cancel with, then your first step is going to be to try to pull something like that out. Right? So let's steal one of these examples. Which one do you think? 68. Go big or go home, right? All right. Making me work for it. So if we've got negative 7 x to the 4 y to the power of 2 plus 14 x to the power of x times y to the power of 3 plus 21 xy to the 4th, I'm going to say that that's equal to, and now I'm just going to look and see. Yeah. So first thing we're going to look at is we can pull out a 7, right? I'm going to keep things a little bit easier on myself and pull out a positive 7, right?
Yeah.
Because if I'm pulling out a negative 7 out of positive 14, that would leave me with negative 2, right? And so it's a little bit harder. So if we pull out positive values, usually it's a little bit easier. And so what we're going to look at is for each of these terms, right? So the coefficient in front, we can usually pull out a common coefficient, right? And so if we pull out a common 7, right, that's going to deal with our coefficients. But then I'm also going to look at, okay, well, what's my highest power of x here? It's 4, x to the power of 1, x to the power of 1. But each of these terms has at least an x to the power of 1. So I'm going to just pull out 7x and then do the same thing for the y's. Y squared, right? I can pull out a y squared, I can pull out a y squared. And so 7xy squared. And then all that's going to be multiplying whatever's left over, right? And so here, I left the negative, right? So I want to put that inside my brackets. And I've got the 7. I've got one of these x's, so I need to keep x to the power of 3. But then I've got the y squared. And so I've got negative x to the power of 3. Now I go on to the next one. I've got 7 out of the 14, so then 7 times 2 makes 14. I've got an x, and I've got 2 of the 3 y's, right? And so I've got plus 2y. And then the last one, right? Now 21 divided by 7 is 3. Plus 3. I've got that x on the outside, so it's taken care of. I've got 2 out of the 4 y's, and so I need y to the power of 2. You can check this, right? Make sure you got the right answer. If you just expand this, right, it should end up being that answer. Right? And so if you're factoring, it's always a good idea to just check to make sure that you got the right answer, right? Because if you expand this out, you should get this, right, where you started.
Would it be wrong if we took out the negative and then just changed the other 2 sides negative?
That would not be wrong. In fact, that would be correct as well. Right? I just like to pull out positives. Unless they're all negative, then yeah, we can pull out a negative. But just as long as you're kind of checking to make sure that you get the same values, you're safe.
It's probably better to maybe say the negative to the end and just pull the negative out of the x cubed plus 2y.
Yeah, you could do that too. Yeah. Yeah.
Just keep them out easier, like you said.
Exactly. Yeah. Yeah, so one option, so what we were talking about here, if you decided to pull out a negative here, you could do this, and then your next step could be to pull out this negative in front, so negative 7x to the, and then y squared times x to the power of 3 minus 2y minus 3y squared. That would be the same thing. Just a matter of what you like. So, all right. A trinomial is something that looks like x squared plus bx plus c, right? And so a trinomial is just a polynomial. Poly means many, right? So a polynomial, but with 3 terms. 1, 2, 3, trinomial. There's the special case where we've got this trinomial, right? But there's no coefficient on the x squared, right? What we're going to fast forward to is just being able to deal with any coefficient. Oh, come on. No, I want to. Well, maybe it's not in this section. We're about to. Oh no, it's in 1.5, isn't it? On those notes that I gave you today. Sorry, 1.5 turned out really small. But then the next page, 1.7, it's a little bit more normal size. What I was leading you into was solving quadratic equations, where you've got just anything like ax squared plus bx plus c, and that's what we're solving for. But I guess we'll settle for this. Just know that we will be able to deal with any coefficient out front here later. Right? So I guess I'm not going to focus on factoring the trinomial. We'll wait until we talk about quadratic equations instead, because that's what we're going to end up using. But it's good practice. Okay. So if you're comparing your special product formulas with the special factor formulas, right? These are all the same. It's just for the special product formulas, we have this equals this, right? This equals this. So again, now for factoring, right, they're going to be a little bit more useful to be able to recognize, right? So being able to recognize that, oh, well, I could rewrite that as a squared minus b squared, for example. Then you would know how to factor it, right? As a minus b times a plus b. So here, these special factoring formulas will be useful to know. Looking at that example that we started with, right, that little bitty example, x squared minus 4, that it turned into x minus 2 times x plus 2, right? Well, because it's part of the difference of squares, right? It's part of the special factoring formulas. And so what we can do is we can rewrite this, oops, as, oh, come on, as x squared, that's fine. But then we can rewrite minus 2 squared, right? We can replace the 4 with 2 squared. And so now, by the special factor formulas, in this case, the first one, right, I've got a squared minus b squared. So now to factor this, I've got a minus b, so x minus 2, times a plus b, x plus 2. So knowing these special factor formulas will be pretty useful, or at least be able to recognize them, right, when they happen, right? Be like, oh, I could probably rewrite this to one of these special factoring formulas. All right. So here, the special factoring formulas 2 and 3 are what we call perfect squares. So those will definitely want to be able to recognize, right? They're a little bit harder than something like a squared minus b squared. But if you've got a squared plus 2ab or minus 2ab, depending on the situation, plus b squared, right? Then if it's plus 2ab, then you have a plus b squared, or if it's minus 2ab, then you have a minus b squared, right? And so those we call perfect squares. Right? And so you'll want to be able to recognize those. They're a little bit harder, like I said, right? But at least if we try to find some perfect squares, then that's good. All right. Okay. Should we try factoring with fractional exponents? We do have to remember how these exponents behave, right? Because we're adding, if we're multiplying the same base, right, then we're adding the exponents, and we could split them up the same way. And so let's see here. Did I tell you guys that the ones with the little pencil beside them means that there was an example very much like it in the textbook, right? And so you have access to the ebook through WebAssign, And so if you go into the ebook, no. I think it logged me out. Hey, what's going on here?
So are there only answers for the ones with the pencils beside them? that we can
No,
do?
but
No.
those have like fully worked out
Oh, okay, I
examples.
see.
If you go find them in the textbook.
Of the web assignment, I heard from a classmate that if we don't buy the textbook by the end of that 14-day trial, it will delete all of our work.
No.
we have done.
No, it'll be linked to your username.
I heard that entirely gets clear that they just shut down.
No, it's supposed to hang tight.
Okay.
So it's supposed to just be there.
But just not be able to access it.
If that happens, I have your old stuff, so I can repopulate it. But because I actually can't see who's bought it and who hasn't. And so that's what makes me think that it should just kind of be fine. It should just be there waiting for you to come back. Yeah. Uh-oh. This projector wants none of it. Which is not ideal, is it? I guess we'll give it a minute. I don't know what else to do. I do have markers, but then it's not in the notes that I post or anything. It's like, no.
Get your hopes up and then there we go.
Okay. I do not know why it did that. Let's see here. I guess I have to see what's going on here. Oh, not that one, that one. 61, 112, 46. And four, 3, 7, 5. That is really annoying. It said unable to connect, but how about you guys work on one of those factoring problems or something? Or just take a break. Works for me too. All right. Hopefully that doesn't happen again. Now I'm scared to change anything. Although I'm pretty sure it's not something that I did. I think it's just, I don't know what I was doing. Which one of these should we go through?
96.
96. Oh, you guys are always going for the big ones. Maybe as a rule, we should just go through the last one. That's what I'm picking up on here. So I'll put it here. Okay. So there's a couple of things going on, right? I've got the x's and I've got an x plus 1, right? And so I can pull out common x's from these ones, or I can pull out common x minus or x plus 1s, right? The problem is that we have this negative 1/2 and positive 1/2, right? Which is just the square root. So there's lots of different ways that we could go about doing this, and let's see where we get. Sometimes with factoring, right? Even if you are working in the textbook and you find a factoring problem that you're working on and you go to check your answers, it's very possible that your answer will not look the same as the answer in the book. That does not mean it's wrong, okay? And so just keep that in mind, right? Look at your answer and expand it to make sure that you got to the right, to where you started, right? Look at the textbook answer, expand it, make sure they got to where you started, right? And then as we progress, right, we can start to manipulate both sides and eventually they'll look the same, right? But as long as you get to the final answer that's the same final answer, then you're good. Yeah. So how do I want to tackle this little guy? I can pull out. All right. I've decided on an approach. I've decided to pull out the common x to the negative 1/2. Because how can I rewrite x to the negative 1/2 or the x to the power of 1/2 as something with an x to the power of negative 1/2?
1
Right.
over x plus.
Yeah, so it would be negative 1/2, and then, well, I gotta write it out here. X to the negative 1/2 times x plus 1 to the 1/2 plus x to the 1/2 times x plus 1 to the negative 1/2. Okay. The only thing I'm going to change here for now, right, just to show you how I'm doing it, is I'm going to rewrite this as x to the negative 1/2 plus whatever else gets me to just positive 1/2, right? And so here, I'm going to have x to the negative 1/2 times x plus 1 to the 1/2. Oh, too tight. Plus x to the negative 1/2, oops, plus 1, right? Negative 1/2 plus 1 would get me to positive 1/2, right? So there will be stuff like that where we kind of have to be like, well, how do I get back to the positive 1/2 if I'm pulling out a negative 1/2? And then that times x plus 1 to the negative 1/2. By the exponent laws, right, I can rewrite x to the negative 1/2 plus 1 as x to the negative 1/2 times x to the power of 1. And so I get x to the negative 1/2 times x plus 1 to the 1/2 plus x to the negative 1/2 times x to the power of 1 times x plus 1 times negative, or to the power of negative 1/2. Okay, so now I have that common x to the negative 1/2 that I can pull outside. So I get x to the negative 1/2 all times, and then the first term is just times x plus 1 to the 1/2. the second term is plus x to the power of 1, which I'll try to draw, times x plus 1 to the negative 1/2. If I expand this back in, I should get back to where I started. We can do the same thing with the x plus 1 as long as we treat it as one thing, right? X plus 1 to the power of 1/2, and then x plus 1 to the negative 1/2, right? So same idea. So what I'm going to do is I'm going to have my x to the negative 1/2 on the outside times x plus 1. I'm going to rewrite the 1/2 as negative 1/2 plus 1 plus x times x plus 1 to the negative 1/2 So now, okay, here we go. Same thing all over again, right? But I will skip the step of writing out this guy, x plus 1 to the negative 1/2 times x plus 1. Maybe I won't skip it. Should show it. Just so you know where it came from. But you can skip it if you're working on your own. So x to the negative 1/2. Rewrite this as x plus 1 to the negative 1/2 times x plus 1 to the power of 1 plus x times x plus 1 to the negative 1/2. Now I can pull out this common factor of x plus 1 to the negative 1/2. So I get x to the negative 1/2 times x plus 1 to the negative 1/2. All that times x plus 1 to the power of 1, which I'll ignore, plus x. And then I've pulled out that common x plus 1 to the negative 1/2. Whew. Yeah. All right.
Would it be easier to just put them under the radical sign instead of?
You could. If you want to talk about the square roots, right? Because we're talking about 1/2. And so a power of negative 1/2 would just say, so for example, this x plus 1 to the negative 1/2, you could rewrite that as 1 over x plus 1 to the 1/2, which is 1 over the square root of x plus 1, right? You're allowed to do that if you find that it's easier, right? Because then it's easier to see what you can pull outside. Like I said, there's a lot of different approaches that I could think of for this problem. Right? We just picked one and went with it. Okay, so one thing is, well, you've got the negative 1/2, but we don't have the same base, right? But we've got the same power, which means we can pull the power outside and multiply inside, right? And so that's allowed because we have the same power. So now we've got x times x plus 1 to the negative 1/2. And in the other set of brackets, right, I've got x plus 1 plus x. I can simplify that as 2x plus 1. So times 2x plus 1. Inside here, right, I can simplify x times x plus 1. And so I get x squared plus x to the negative 1/2 times 2x plus 1. And then if we wanted to,
Why isn't it x squared plus 1?
If we
Where?
cut the x through.
This one or this one? A
Oh,
or B?
sorry, because we have to, yeah, never mind.
Okay. Cool. I know, talk it out, it's good. So here, I would say we're done factoring, right? If you wanted to rewrite it a little bit nicer, right, we said that anything to the power of -1/2, the negative moves it to the denominator. The 1/2 means take the square root. And so we can rewrite this as, or it's equal to 2x plus 1 over the square root of x squared plus x.
When we want to move this, the radical to the top, out of the denominator.
We could rationalize the denominator. Nah. This turned into a massive example, which is good, right? So what we're talking about is, well, do we really want a root here in the denominator? No, right? And so probably not. It depends on what we're doing, right? If we have a square root up here that we want to cancel with, then maybe it's not a problem, right? But either way, we could rationalize the denominator, which we talked about last day. But let's leave it here for now, right? You get to here, I'll be so pleased. But good. Good, good, good. All right. All right. I know the drill. Do the last one. Got it. So just as a rule, it's going to be a lot easier to factor things if the first thing that you do is pull out a common, like pull out all the common factors that you see, right? And then start to look for those special products, right? That type of thing. And so if we have to factor completely, I'm assuming you want to do the last one. Sure. So we've got a squared plus 2a all squared minus 2 times a squared plus 2a minus 3. All right, here we go. I'm going to write it out here. A squared plus 2a squared minus 2a squared plus 2a minus 3. To talk about see, I would group the terms, right? So your notes go through and tell you how to group the terms, right? I would probably group these, right? Because you've got the a squared plus 2a and the a squared plus 2a. So what we could do is we could kind of manipulate it a little bit that way. How else are we supposed to do this? Well,
If you, I don't know, if you distribute the square into the first term, then you can pull out an a squared, and then you have a squared plus 4, and then if you pull out an a on the other one, then you also have oh sorry, if you pull out a 2, oh no, that doesn't.
what I'm seeing is I've got a term squared and then minus 2 times that same term, right? So the only holdup here is my minus 3, right? To be completely frank with you, I don't see the most obvious way to do it unless you did. Because you've got a squared plus
Oh, no, you can't, because then
minus
you can make that a squared plus 4, I think you should be able to,
so you want to rewrite the 3 as a square. Oh, but what we can do, what if we rewrote -3, right? So what I'm looking at here is essentially I've got this a squared minus 2ab. I'm just going to force it to look like one of those special products. What are they called? The factoring blah blah blahs. Yeah, the special factoring formulas. So I'm going to make it look like a perfect square. So 2ab, and then here I need plus b, right? It doesn't look like that. Oh, sorry, plus b squared. It doesn't look like that right now, right? Because I'm missing this b, and well, -3 doesn't look like a plus b squared to me, right? So what I can do is I can rewrite -3 into something like, I don't know, plus 2 squared. Because I want the plus. Maybe I'll do -2 squared plus 1. How about that? Let's see where it gets us. Right, so -3 is the same as, oh yeah, because I want b to be 1, right? Because there's no other term in the -2ab term, right? So I want b to be 1, and so I can rewrite this as but I want plus b squared, so I want 1 minus 4. Right? So then I can rewrite my -3 as plus 1 minus 4. And then what I'm going to get is then I have a squared plus 2a squared minus 2 times a squared plus 2a. Oh, whoops, ran out of room. You know what? I'm going to scoot this to the next line. It got too big. Plus 1 minus 4. 1 we can rewrite as 1 squared. Right, so 1 squared, and then our plus b squared is going to be that plus 1 squared. So now what I'm going to do to make things convenient for myself, knowing these perfect squares, is I'm going to section that off and then put the negative or the -4 on at the very end. Right? As long as you don't change the meaning of things, right? -3 can be replaced by 1 minus 4. That's allowed, right? So as long as you're not changing anything by its meaning, then the special factoring formulas say that, okay, well now, right, this can be rewritten as a minus b squared. Right, that's a special factoring formula because it's a perfect square. And it's minus because you've got the -2ab. So now I can rewrite everything in the light blue brackets here as, well, if a is a squared plus 2a. I'm just treating that as one thing. Then I get a squared plus 2a minus b, which is 1, all squared minus 4.
That a squared plus 2a, it doesn't have to be in the bracket, right?
No, it doesn't. Not anymore. I'm just being overly cautious with the brackets. So yeah, if you are doing it and you see that, oh, I don't need these brackets, that's totally fine, right? But I'm keeping them on there until but maybe that's a good move now, right? A squared plus 2a minus 1. That looks like another perfect square, doesn't it? A squared plus 2a minus 1 squared, right? We could manipulate it a little bit. Uh-oh. You might just get the Friday of your dreams and a little bit early. Hey, I wouldn't mind either. I want that good lunch that's going on in the cafeteria. Have you guys noticed there's all the new stations going on?
Oh, yeah.
I love when they start the new stations. Like,
They have like a community station now or something like
mm-hmm.
that.
Yeah, there's a sandwich station, there's a salad station. They've had like pad thai, bibimbap. They've got all these sushi. It's awesome.
The cafeteria. Oh, I don't know why you used to need people.
Oh.
You know how when they have those, like, actually, they actually have food there, I was thinking that.
It's like, what's going on? Yeah. No. In the
Okay.
a little bit more normal. How about we leave it for now? So a squared plus 2a minus 1 squared minus 4. Right. In the interest of moving on, right? But what we could do is we could say, oh, well, I could manipulate this minus 1 and force it to look like another perfect square inside a perfect square, right? But let's just leave it here. Okay. But this tool of being able to rewrite something that's not quite working out, right? And being able to recognize, oh, this looks like one of those factoring formulas, right? How can I make it look like that? And then it's going to be way easier. So, kind of similar idea. If you're factoring by grouping terms, right? And that's kind of what we did, right? We said, well, these terms can be factored into a perfect square, right? And then I've got this little guy on the end, right? And so that's the idea that we used here. The factoring by grouping terms is if you've got things that, right, like this, x to the power of 3 plus x squared plus 4x plus 4, right? I see 2 4s here, right? Or even 2 multiples of 4. And I see the x squared and the x to the power of 3. So I'm just going to separate those, right? I can arbitrarily write brackets around these guys, right? And then I can pull out from those brackets, right? I can pull out common factors, right? So we can kind of zoom in on a section that we know how it behaves, right? And then factor out that way. But then what's important, right, is after you pull out a common factor of x plus 1 from these guys, right, then on the outside you've got x squared plus 4 as one term. Okay. How about we try to get through, because we've actually talked about rational expressions already. Rational expressions, meaning just we've got fractions, right? And so we talked about the rules of fractions, I think maybe on the first day that we covered material. So just remember, right? If we've got a fraction, so section 1.4 is called, what was it, fraction or rational? Yeah. Is on rational expressions. Just a reminder, right? If you have a fraction, that's going to be just in general a numerator over a denominator. The numerator is on top because it's numero uno. That's how I have to remember it. Well, now I don't have to remember it, but that's how I had to remember it. And so, and then the one on the bottom is the denominator, right? Because we need to be able to talk about these things. And so, just going through these things, we're going to start talking about the domain of a function pretty soon, right? Here's a little sneak peek, but as a rule, I'm going to steal these into the notes. And I think we kind of mentioned the domain, but I'm also teaching a calculus class, and the first couple of weeks we do a review of pre-calc, so it's been really confusing for me. Because did I tell you guys or did I talk to them about it? But the rules for our domain is that we cannot divide by 0, right? So if you have 1 over x, right, or something like it, then all the x's that make you divide by 0 can't happen, right? So they're not in the domain. Domain just meaning the possible values of x. And so here, I'll add that on here. The domain is the possible values of x. So here, the rules for the domain is that we can't divide by 0. Can't divide by 0. So any x that makes you divide by 0 is out of the domain, right? We can't take the square root of a negative number. So we can't take the square root of a negative. Negative number, I'll say. And then the combination of those, right? Now we've got 1 over root x. Well, in the square root, we can't have a negative number, but also because we're dividing, we're allowed to take the square root of 0. It would just give us 0, but we're not allowed to divide by 0. So then our domain is that all the x's where x is greater than 0. So if we have to find the domain of an expression, I guess I know the drill. Last one. It is also, well, this one definitely is the hardest of those, I think. So if we have to find the domain, I'll move this here. Find the domain of the square root of 2x over x plus 1. Okay? So we need to keep those rules in mind, right? And so from this portion here, we know we can't take the square root of a negative, right? So that's the rule from the root 2x. And then down here, we can't divide by 0. So usually how I approach this is I figure out, okay, well, what values cannot happen, right? Because that's easier. And then I go from there. So keeping them color coded, in the square root of 2x, we know 2x has to be greater than or equal to 0, right? It's allowed to be 0 if it's not in the bottom, right? And so it has to be greater than or equal to 0. And so solving for x, well, that means that x should just be able to divide by 2, I guess. 0 divided by 2. So x has to be greater than or equal to 0. But x could be 1/2. Yeah? Yeah. Okay. Okay. It works. Dang it all, the math, it works. So x is greater than or equal to 0. Sold. Is the rule. Oh yeah. I don't know why I was pausing. Anyways, it's been a day. This makes sense, right? Yeah, right? Okay. So yeah, it's doable. Because I'm allowed to use this as an equal sign, this inequality. In fact, I'm not sure we've even gotten into inequalities quite yet, but we have seen them, right? And so I'm allowed to look at this inequality as an equal sign. And so if I'm solving for x, then I would divide both sides by 2, right? And so that's where 0 divided by 2 is just 0. So x has to be greater than or equal to 0, making it a positive number, satisfying the rules. Nice. Phew. But we also, and x plus 1 cannot equal 0, right? The rule was we can't divide by 0, which means that x plus 1 cannot equal 0. But the not equal to we can treat as an equal sign, right? And so then we get x cannot be -1, right? Subtracting 1 from both sides. The key here is that both of these conditions have to be satisfied at the same time, right? And so if we're looking at a number line, let's say, here 0, 1, -1, -2, 2, and it just keeps going and going. Because I find it helpful if we look at the first condition, x has to be greater than or equal to 0, which means that, okay, well, on this number line, I'm allowed to be 0, right? So I'll do a closed dot, and anything greater than that, right? And then x can't be -1, has to happen at the same time. That's not really an issue, because what it's saying is that it's allowed to be any of these values as long as it's not -1, right? But the only portion of overlap here is from 0 onwards. Right? And so here, actually it's inclusive. Is the overall domain, right? Where both of those are satisfied. And so the domain if we want to use the same notation that the little box used, right, the domain is the set, right, so curly bracket of all x's, straight vertical bar such that x is greater than or equal to 0, and set. Right. And how we read this is we say the set of all x such that x is greater than or equal to 0. All right. Say that again. No. Okay. I'm running out of battery. I'm running out of time. I'm running out of everything. So how about, so you've probably worked through the rest of these, right? On Tuesday, we'll just go through and do the last one of each of them. And if you have any more that you want to go through, then let's do it. But also work through 1.5 and 1.6. Remember, we're not doing we're not doing 1.6. 1.5 and 1.7 are what we're doing. Okay. So work through those. And I'll see you guys on Tuesday. How about? Any questions though before we start or end? It has been a really long day. No questions. All right. No. No 1.6. Oh, one thing, sorry, while you're still here. One thing I did put on Moodle, tried to explain it there. I explained it in class last day too, but I put a little note here. So all assessments labeled quiz, there's one for each section, right? Those are gonna make up your assignment marks. And I see that some of you have already tried up to 1.10, that's awesome. And so if you go to WebAssign, there's also gonna be ones called homework. Those are just for extra practice. So those are not for marks, right? And so I want you to know that because they're quite a bit longer, right? So down here, right, looking at more. On your end, it'll look a little bit different. I guess I could go to student view. It's much nicer on your end. All right. So you've got all these quizzes. These quizzes are your assignment marks, right? And then there's homework. Homework, 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 not for marks, just for practice, right? So if you feel confident in 1.1, 2, 3, but then maybe 1.4 you find really difficult, try the homework, right? Work on it some more. And then there's even a chapter 1 kind of review little quiz too, but those are not for marks either, right? Only the quiz ones are for marks. Cool. Any questions? Let's get to the CAF before they close. And I'm at 2%. Great. Let me just